44500 Newton, and area of cross section of copper, that is 15.2 millimeter by 19.1 millimeter. Now we have to find strain, and Young modulus of copper is given. So by that formula, Young modulus is equal to stress upon strain, but here longitudinal, that's why I have to write sigma L upon epsilon L. We have to find this epsilon L, so to subject epsilon L is equal to sigma L upon Y. Now what is sigma L? Sigma L is FL upon A upon Y. So I can write F upon A into Y. This is longitudinal force, right? Now is equal to FL. Now what is area? Area is length into breadth into Young modulus. So now we have all the values. What is L? 15.2 millimeter. Milli means 10 raised to minus 3. B is 19.1 millimeter. Y we have, right, and force is 44500. So by putting all the values, we can get we can get strain. In this numerical 9.9, we have steel cable of radius 1.5 centimeter. Maximum stress of that steel cable 10 raised to 8 Newton meter to inverse. So what is the maximum load the cable can support? So simple formula for that, maximum stress is equal to maximum force upon cross section area. So from this equation we have to find that maximum force. Maximum force is in the form of maximum load. So maximum force is equal to area into maximum stress. Now area, for area I have to write pi r square, but see here it is in centimeter, we have to convert it into meter. So into maximum stress is 10 raised to 8, right? So here we have to take R is equal to 1.5 into 10 raised to minus 2 meter, right? So by putting all the values, we can get maximum load or maximum force. So in this numerical, here we have two wires, both the masses are same and lengths are same. So we have to find ratio of their diameters. So here we have to find ratio, means copper diameter upon iron diameter. So here we have to start from that formula Young modulus, which is main formula here. So stress upon strain. See here, strain will be same in both the cases, both the wires. So strain, if we subject that, so strain will be F upon A into Y, right? Now strains are same, so that's why I can write F upon A copper Y copper is equal to F upon A iron Y iron, right? See here, forces are same. Why forces are same? Because we hang one load which is means both the wires have same load, that's why force will be same, right? So F can be cancelled out. Now we have to put Y in one side and areas in one side. So Y iron upon Y copper is equal to A copper upon A iron. Now what is the formula of area? Area means here pi r square, right? So pi, we don't have r, we have to find that diameter. So d copper square by 4 upon pi d iron square by 4. So pi by 4 gets cancelled out, we are left with d copper square upon d iron square, right? So now we have to find this d copper upon d iron. So to find that, here d copper upon d iron is equal to, we know that here y fe upon y copper, right? So here there was square. So to find that, we have to find square root of this equation. So root YFE upon Y copper. So by putting all the values here, we can get ratio of diameter of copper and diameter of iron. In this numerical, we have one mass which is of 14.5 kilogram, which is fastened to end of a steel wire of unstretched length 1 meter. So length is 1 meter. Now that wire here, it is moving circularly. So it have angular velocity 2 revolution per second. So that is its frequency. And cross section area of that wire is 0.065 centimeter square. We have to convert it into meter square. So area 0.065 into 10 raised to minus 4 meter square. Now first we have to find force, because here that object is circularly moved. So mv square upon r, we have to put centripetal force. Now we can convert this into angular velocity. We know that formula v is equal to r omega. By putting here, we get f is equal to m r square omega square upon r. R gets cancelled out, so we are left with m r omega square, right? So we have m, we have r and omega. What is r here? R is exactly the length of our wire, and omega, that we need to find. Omega, see, omega is equal to 2 pi f, that formula. So 2 pi, and here frequency, it is 2 revolution, means 2 oscillations. So 2 pi into 2, so it will be 4 pi radian second inverse. Now we have to find total force. One force is because of circular motion, and another force is because of its own weight. So weight plus centripetal force. So weight is its formula is mg, and centripetal force formula is mr omega square. So by putting all the values, now we know that all values, right? At last we get 2429.5 Newton. Now here we have to find elongation. To find elongation, Young modulus simple formula, and it will be FL upon A delta L. So just delta L subject, FL upon AY. Now we have force, length 1 meter, area that is comes from here, and Young modulus of steel, that is 2 into 10 raised to 11. So by putting all the values, we can get elongation. In this numerical 9.12, we have initial volume, which is 100 liter. Pressure increase 100 atmospheric, right? We have to convert it into Pascal, so we have to multiply it with 1.013 into 10 raised to 5 Pascal. After that, we have to convert this liter into meter cube. So 100 into 10 raised to minus 3 meter cube, it will be 0.3 meter cube. And this is also 100.5 into 10 raised to minus 3 meter cube, right? Now see, question is, compare the bulk modulus of water with that of air. So bulk modulus of air is 1 into 10 raised to 5 Pascal. So compare with that air, right? So first we have to find bulk modulus of water. So bulk modulus of water, pressure upon change in volume. So PV upon delta V. So by putting all the values, now we have all the values, pressure, volume and delta V. What is delta V? Change of these volumes, right? So delta V is equal to V2 minus V1 is equal to 100.5 minus 100 into 10 raised to minus 3, right? So it will be 0.5 into 10 raised to minus 3 meter cube. Now to compare, we have to find a ratio of BW upon BA. What is BW? Bulk modulus for water and bulk modulus for air. So by comparison, by putting values, we can get 2.026 into 10 raised to 4. That means here ratio is very large, because gases are more compressive than liquid and intermolecular distances in liquid are very small compared to gas. In this numerical, density of water at a depth that we have to find, so symbol of that is rho dash. Density of water at a surface is rho, water mass m and volume v at surface and v dash at depth. So this sum starts from that formula, density is equal to mass upon volume. So to find volume, subject that mass upon density, right? And similar v dash at depth, v dash we get m upon rho dash for depth. Now change in volume at surface and depth, so that will be delta v is equal to v minus v dash. So it will be mass upon rho minus mass upon rho dash. M common, we can write 1 upon rho minus 1 upon rho dash. Now change in volume means here strain of volume delta v upon v is equal to m, here bracket 1 upon rho minus 1 upon rho dash into, for v we have to put values formula rho upon mass. So v formula is rho upon m. Now multiply this term here, we get rho upon rho, rho upon rho, mass gets cancelled out, so minus rho upon rho dash. So it will be 1 minus rho upon rho dash. So this is volume strain, 1 minus rho upon rho dash. Now compressibility. Why compressibility? Compressibility value is given in our data. So compressibility K is equal to 1 upon bulk modulus, right? So 1 upon bulk modulus formula is delta V upon PV. So 1 upon P into the bracket 1 minus rho upon rho dash. Now by putting all the values we can subject rho dash, because see we have pressure is 80 atmosphere, so 80 into 1.013 into 10 raised to 5, that is in Pascal. Compressibility is also given, K is equal to 45.8 into 10 raised to 11 minus 11 here. Then density 1.03 into 10 raised to 3. So by putting all the values we can get rho dash. In this 9.14 we have to compute the fractional change in volume of a glass slab. So hydraulic pressure is given, it is 10 atmospheric. So bulk modulus formula that we know, B is equal to P pressure upon volume strain. So delta V upon V if subject, then P upon B. We know that atmospheric pressure, so 10 into 1.013 into 10 raised to 5 Pascal upon bulk modulus, right? So bulk modulus of glass slab is 37 into 10 raised to 9. So by calculating all the values we can get delta V upon V, and after that finding delta V upon V, we have to compute that delta V upon V into percentage. So I have to multiply it with 100. So whatever will be our answer, we have to multiply with the 100 to find fractional change in volume in percentage. This numerical we have to find volume contraction, so we need to find delta V. Now length is given of that cube which is made up of copper, that is 10 centimeter. So 10 centimeter into meter will be 0.1 meter. Hydraulic pressure is 7 into 10 raised to 6 Pascal. Now to find delta V, that we have to write bulk modulus formula, bulk modulus P delta V upon V. But here in that formula, if volume contraction will be there, we have to write negative sign here. So here B is equal to minus PV upon delta V. Now subject delta V is equal to minus PV upon B. We have all the values here. What is the value of bulk modulus for copper? So it is 1.4 into 10 raised to 11, right? It is in Newton meter to inverse. So by putting now all the values we can get delta V. It is in now meter cube and it is negative also. In this numerical, question is how much should the pressure on a liter of water be changed to compress it by 0.10 percentage. So 0.10. So we can find delta V upon V is equal to 0.10 upon 100 because it was in percentage. So bulk modulus formula now B is equal to minus P delta V upon V. Now from this equation we need to find P. So P is equal to minus B delta V upon V. Right. Now bulk modulus, it is given and that value is 2.2 into 10 raised to 9. Here I have to write negative into again negative 0.10 upon 100. So after calculating we get 2.2 into 10 raised to 6 Newton meter to inverse. So that is our pressure, right? So this pressure have to be applied on a liter of water that compress by 0.1%.